Hello and welcome. Today we'll be talking about two distinct types of power plants. First, we'll be discussing the geothermal power plant or geothermal energy. Now, could one of you please read the definition of geothermal power plants?
So, geothermal power plants are used in order to generate electricity by the use of geothermal energy, the Earth's internal thermal energy. So, they essentially work the same as a coal, solar, thermal, or nuclear power plant. The main difference being the heat source.
Thank you. Okay, so one of you please read again the working principles of the geothermal power plants.
Okay, so working principles. There is a natural source of power found below the surface of the earth. Has been around for centuries. Underground, far below us, there are pools of water heated by magma or molten rocks. These pools of water make up our geothermal reservoirs, harnessing the power of the earth's temperatures to power, heat, or cool our homes and business is the essence of geothermal power.
Thank you. So, geothermal power plants use hydrothermal resources that have both hydro and heat or thermal. Geothermal power plants require high temperatures around 300 degrees Fahrenheit to 700 degrees Fahrenheit. Hydrothermal resources that come from either dry steam wells or from hot water wells. People use these resources by drilling wells into the earth and then piping steam or hot water to the surface. The hot water or steam powers a turbine that generates electricity. Some geothermal wells are as much as 2 miles deep. Here we have the ranking of the largest geothermal power plants in 2018 at least. We have the geysers from the United States, around 900 megawatts, and Landerello from Italy, around 769 megawatts. There's a very distinct gap here, significant gap of around 200 plus megawatts. You'll see why later, because there are different types of geothermal power plants. Here we have the top 10 geothermal countries. You can see here the gap from before. It's actually because the United States is the top geothermal countries in the world. And actually Philippines coming in at third. Here we have the Macban geothermal power plant. You can see here, these rising piles of smoke as actually steam. It's being heated up. Here we have the Gevsers geothermal power plant. Again, similar configuration from before. You have these like large chimneys, or lack of a better term. Okay, so could one of you please read the ideal location for geothermal power plants?
So, ideal location. So, the most active geothermal resources are usually found along major tectonic plate boundaries where most volcanoes are located. So, one of the most active geothermal areas in the world is called the Ring of Fire, which encircles the Pacific Ocean. So, when magma comes near the Earth's surface, it hits the ground, trapped in porous rock or water running along fractured rock surfaces and faults. So, hydrothermal pictures have two common ingredients, water or hydro and heat, which is thermal.
Thank you very much. Could one of you please continue?
Okay, so ideal location. Geologists use various methods to find geothermal reservoirs. Drilling a well and testing the temperature deep underground is the most reliable method for locating a geothermal reservoir. These reservoirs are deep underground and are largely undetectable above ground. Geothermal energy finds its way to the Earth's surface in three ways: volcanoes and fumaroles, or the holes in the earth where volcanic gases are released, hot springs, and geysers.
Thank you very much. Okay, so underground rocks with high thermal gradient. The permeability of these rocks allow the flow of liquids, and the perpetual supply of fluids are the main requirements of a geothermal source. Okay. Generally, the locations near to places with volcanic activity, like before, the Ring of Fire engulfing the Pacific, rather. Places with geysers, hot water springs, and the like are potential geothermal sites. Areas subject to tectonic plate movements and frequent earthquakes are also potential areas. However, it is not necessary that these have to lead to a viable thermal reservoir. These could There could be blind geothermal resources as well as no indications at the top surface. We have the volcanoes and I believe it's fumaroles. We have volcanoes. You can see the heat rising. That's steam. That's the groundwater trapped in the porous rock getting vaporized into steam by the geothermal energy underground. We have hot springs. I don't believe we have these in our country, but I think these are popular in some other countries like the United States. I believe this is the Yellowstone hot spring, if I'm not mistaken. And we have a geyser. And see, this is actually heated water, steam, bubbling up into a sort of explosion into a single spot. Think of it like a big pimple of the earth that gets popped like this every so often. I believe a famous one would be the Old Reliable in the United States again. Here we have the different types of the geothermal power plants. First one would be the dry steam power plant. Could one of you please read?
So dry steam power plants. So dry steam plants are the most common types of geothermal power plants, accounting for about half of the installed geothermal plants. So they work by piping hot steam from underground reservoirs directly into turbines from geothermal reservoirs, which power the generates to provide electricity. So after powering the turbines, the steam condenses into water and is piped back into the earth via the injection well.
Thank you very much. Let's see, dry steam, meaning we don't really use water in this scenario. We directly use the steam coming from the geothermal source and pipe it directly into a turbine to power a generator. And then the condensed water just goes back into the earth. That's why it's called dry steam. Here's a working diagram of the dry steam. You can see here, the steam goes in through this pipe into the turbines and spins the generators. The generator output goes to generating facility and the condensed water goes back into the earth via this injection well. Okay, now we have the flash steam power plant. Could one of you please read?
Okay, so flash steam power plant. So flash steam power plants differ from dry steam because they pump hot water rather than steam directly to the surface. These flash steam plants pump hot water at a high pressure from below dirt into a flash tank on the surface. The flash tank is at a much lower temperature, causing the fluid to quickly flash into steam. The steam produced powers the turbines. The steam is cooled and condenses into water, where it is pumped back into the ground through the injection well.
Okay, thank you very much. Now, the flash steam is somewhat similar, but there is another step in the process. Rather than using steam directly, it uses the superheated water that has not yet evaporated into steam. Now take note that the groundwater that's present in these geothermal power plants can be under um, a lot of pressure, meaning that they do not exactly vaporize into steam. But if you introduce them into a lower pressure area, such as the flash tank, they instantly vaporize into steam, or flash as it calls here. And that's what we use to power the turbines. And then the process is the same as before. We just pump the condensed water back to the earth using an injection well. We have here another working diagram of the flash. See here, the super hot water that's about to turn into steam gets pumped into this chamber here. It's a lower pressure compared to the underground of the Earth. And then it vaporizes into steam, which powers the turbines and so on. And then generating facility, once again, the water condenses and we pump it back into the Earth and the process continues. Finally, we have a binary cycle power plant. Could one of you please read?
So binary cycle power plant. So in this binary cycle plants, the main difference is that the water or steam from below the earth never comes into direct contact with the turbines. Instead, water from geothermal reservoir is pumped through a heat exchanger where it hits a second liquid like iso- isobutene, which boils at a lower temperature than water. So this second liquid is heated into steam, which powers the turbines that drives a generator. So the hot water from the earth is recycled into the earth through the injection well, and the second liquid is recycled through the turbine and back into the heat exchanger where it can be used again.
Okay, so thank you very much. Now, the binary cycle power plant is similar to other processes like the nuclear power plants, wherein we use the heat to boil water into steam, which then spins a turbine. But in this case, we use the super hot water from the geothermal energy source to boil some liquid that boils at a lower temperature than water, which in this case would be isobutene. And then the process is the same as the previous two. We have a working diagram of such a power plant. You see here, we pump the super hot water here to a heat exchanger. The heat given off by the water heats up the lower boiling point liquid here that vaporizes into gas and powers the turbines. And it just cycles back into the heat exchanger again after it condenses back into a liquid. See here, the water just goes back into the earth after we make use of its heat. Now, construction costs. The initial cost of a geothermal power plant construction is high, but operational costs soon become relatively low. This means that even though geothermal energy becomes financially worthwhile in the end, the cost of power plant construction may put geothermal energy out of the question. Yes, this is because of the location requirements, very specific compared to other power plants. We have some advantages. One of you please read?
Okay, so for the advantages, so some advantages of the geothermal power include its sustainability and consistency. Geothermal energy is renewable, so it's both more environmentally friendly and less susceptible to natural resource wars than fossil fuels are. Geothermal can consistently produce energy output 24/7, regardless of weather conditions or seasonal changes.
Thank you very much. Yes, it's actually very environmentally friendly since we're making use of the already present geothermal sources of the earth. And they also output energy constantly at 24/7 as long as that geothermal energy source is present, regardless of weather conditions, time of day, seasonal changes, etc. Of course, we have disadvantages. Could one of you please read?
So the disadvantages of geothermal power plants are the geographic limitations and high cost associated with power plants construction. So this needs to build over regions with underground reservoirs of hot stream or water. So through it's technically possible to engineer enhanced geothermal systems or EGS in unsuitable environments, it's highly impractical to do so. So EGS requires extensive space, planning, construction, government oversight, and capital, and can only be accomplished by federal or state governments and corporations.
Yes, thank you very much. As stated before, the high cost is associated with this kind of power plant because the locations are very limited in where you can set them up. So now we move on to hydroelectric power plants or hydropower. Hydroelectric power plants, working principle. Hydropower plants capture the energy of falling water to generate electricity. A turbine converts the kinetic energy of the falling water into mechanical energy. Then a generator converts the mechanical energy from the turbine into electrical energy. So think of like a waterfall. We use the momentum that's carried by the falling water in order to spin a turbine and generate electricity. We have the largest hydroelectric power plants in the world. We see the Three Gorges Dam, I believe, from China, with a rated capacity of 22,500 megawatts. Impressive. And it was only built in 2012. And we have the Itaipu Dam in Brazil, 14,000 megawatts, built in the 90s and maintained in the 2003, I think. So, will we please read the largest hydropower in the Philippines?
Okay, so largest hydropower in the Philippines. So, Magat Dam. The Magat Hydroelectric Power Plant is one of the largest hydro facilities in Luzon with a maximum output of 380 megawatts. So the construction of the dam started in 1975 and was completed in 1982. It is one of the largest dams in the Philippines. It is a multi-purpose dam which is used primarily for irrigating about 85,000 hectares or 210 acres of agricultural lands, and power generation through the Magat Hydroelectric Power Plant. So the dam is located within the boundaries of Namilangan, Alfonso Lista, Ifugao, and Ramon. And lastly, Ramon Isabela. Note, Ilihan combined cycle power plant and solar power stations is the largest in Philippines with a generating capacity of 1,200 megawatts. Luzon Grid has a total capacity of 14,348 megawatts. Three Gorges Dam in China has a capacity of 22,500 megawatts.
So thank you very much. So as you would expect in a tropical country where it is either raining or sunny, we largely use the hydropower. It could very be possible that the power we use right now comes from this power plant here in Magat Dam. Okay, so we have the largest hydroelectric power plants again. So could one of you please how it operates the dam section?
So most hydropower plants rely on a dam that holds back water. So creating a large reservoir, often this reservoir is used as a recreational lake, such as Lake Roosevelt at the Grand Coulee Dam in Washington State.
Okay, so thank you.
Intake. Intake. Gates on the dam opens and gravity pulls the water through the penstock, a pipeline that leads to the turbine. Water builds up pressure as it flows through this pipe. So turbine, the water strikes and turns the large blades of turbine, which is attached to a generator above it by way of a shaft. Generators. As a turbine blades turn, so do a series of magnets inside the generator. Giant magnet rotates past copper coils, producing alternating current by moving electrons.
Well, thank you very much. So here we see the working principle of the hydroelectric power plants. First, we see the dam part, wherein we build a dam in the outlet, for lack of a better term, of the large body of water, which acts as the reservoir for our hydroelectric power plant. The dam, let's say, funnels the water into a smaller portion in order for us to power a bunch of turbines. Here we see in the intake, the gates on the dam open and gravity pulls water through the penstock, a pipeline that leads to the turbine. The water builds up pressure as it flows through this pipe because it's a smaller section, but there's a lot of water trying to flow through that section. So pressure builds up. This pressurized water then flows into the turbine and thus spins the generator, producing electricity. Okay, so why don't we please read the next one?
Okay, so for transformers, so the transformer inside the powerhouse takes the AC and converts it to higher voltage current. So power lines, out of every power plant come four wires. The three phases of power being produced simultaneously, plus a neutral or ground common to all three. So last is the outflow. So used water is carried through pipelines called tail races and re-enters the river downstream.
Yes, thank you very much. So the generator output goes to a transformer. It converts it into a higher voltage for better, let's say, transmission across the power lines across the country. You see the power lines. There are four wires. It's a three-phase system with a common ground or neutral. And finally, we have the outflow, wherein after we make use of the kinetic energy of the falling water, we then send that water back downstream in order to less disrupt the ecosystem. We see a working diagram of such a hydroelectric power plant. We see the reservoir, a lake, or something that's higher up, a body of water that's higher up. We see the control gate, which controls the flow of water. We can either close or open this if the reservoir is running out. The penstock, here we see the intake. This is what the intake part here, penstock. See the dam portion right here. Finally, we have the turbine, which gets spun by the flowing water at increased pressure here and goes out to the outflow. Turbine spins the generators and gets the voltage gets stepped up for transmission across the power lines. You can see a more detailed diagram of a hydroelectric power plant. It's a different diagram, but it's the same working principle. Okay, so construction. One of you please read.
Okay, so a hydroelectric power plant. So hydropower. So construction of hydroelectric power plant. So the construction of this dam is difficult and about intensive. So before construction begins, water is diverted or prevented from moving through the construction site. After water is diverted, the foundation area is cleaned, excavated, and rock or sediments that will act as a foundation are repaired and deemed solid. This is done to ensure the rock or sediments won't shift or fall as a result of the load of the dam and reservoir. Supports known as rock bolts and netting may be used to prevent rocks from falling on the dam. Forms are then built along the edges of the dam. Rebar is placed inside and concrete is pumped in. This is done in sections and the concrete is poured bit by bit in the block formations. Once enough of the dam is built, the reservoir is allowed to fill in a highly controlled manner. The dam is monitored during this process. Other structures that make the dam operational are then added.
So thank you very much. You see the construction of the hydroelectric power plant. You can see that it is definitely difficult and labor intensive. We saw before that it took around half a decade to build the power plant here in the Philippines. Now, before the construction begins, of course, we have to prevent the water from disrupting construction, right? So we either divert it or block it entirely. So that, well, we just simply build a dam. That's about it. Construction of a hydroelectric power plant is basically akin to just building a dam. Okay, so here we have hydropower dam design. An arch. Here we have a solid gravity dam. tailwater level, headwater level. We have the arch dam right here. And we have a buttress dam. Yeah, see, because it has a concrete buttress. So we're just gonna skip over this. This is a very technical blueprint of a kind of dam. So we move on finally to the main factors that determines the dam power output. Okay, so want to please read?
So the amount of the electricity a hydropower plant produces procedures depends on two factors. So first one is how far the water falls. The farther the water falls, the more power it has. Generally, the distance that the water falls depends on the size of the dam. So the higher the dam, the farther the water falls, and the more power is directly proportional to the distance it falls. In other words, water falling twice as as far as has twice as much energy. So the second one is amount of water falling. So more water falling through the turbine will produce more power. The amount of water available depends on the amount of water falling down the river. Bigger rivers have more flowing water and can produce more energy. Power is also directly proportional to the river flow. A river with twice the amount of flowing water as another river can produce twice as much energy.
So thank you very much. Now we can think of these two factors as the formula for force, right? Mass times acceleration. If we have greater acceleration here in how far the water falls, the time it as the water falls, it builds up velocity, right? It accelerates more. If it has more time to accelerate, it has more acceleration, then it has more force when it hits the turbine. Now, with the finally we have the mass part of the formula. We have the amount of water falling. So if we have more mass or more water falling and hitting the turbine, then we can consequently have produce more power and thus make the dam more efficient. So we have the tallest dam. Currently, the tallest dam in the world is the Nurek Dam on the Vax River in Tajikistan, around 984 feet, 300 meters tall. Hoover Dam is 716 feet, 222 meters tall. Today, Hoover Dam still ranks in the top 20 of the tallest dam in the world, but only in concrete, gravity, and arch categories. Here we can see that this may be the tallest dam in the world, but it's not the most. It doesn't produce the most power. We saw that the one that produces the most power was the one in China, because once again, as we stated before, the generation of the hydroelectric power plants depends on several factors, and that varied depending on where you build the dam. Okay, so here we have a few cases of dam failures. We have the Bangyao Dam in Henan, China, 1975 dam failure. We can see a lot of people died from the dam, probably drowned from the resulting flood. Finally, we have the Machhud Dam. I don't know how to pronounce that. The Machhud Dam to collapse, leading to the deluge of the city of Morbi and surrounding rural areas. So again, a lot of people died from the flooding. We have the Oroville Dam in California. I don't think anyone died here, but because the evacuation of 180,000 people. That's recent too, in 2017. Okay, so I think that's it, guys. Thank you for listening.